Students, welcome back to our YouTube channel. My name is Teacher Mati, and today we're going to look at photoelectric effect question, a chapter in Form 4 Physics syllabus. Our question reads, the cutoff wavelength for a certain material is 3.310 times 10 to the power negative 7 meters. What is the cutoff frequency of the material? Now, basically, photoelectric effect is the process by which light of sufficient energy causes electrons to be ejected from the metal surface. So we have light, and that light must have sufficient energy. So in some cases, the light may have a lower energy, and that lower energy cannot cause photoelectric effect. And when the light has sufficient energy, the exact energy that can cause photoelectric effect, that exact energy is called the cutoff energy. And that cutoff energy has the cutoff wavelength and the cutoff frequency. Now, when we are talking about the cutoff wavelength, we mean the minimum wavelength that can cause photoelectric effect. When we talk about the cutoff frequency, is the minimum frequency that can cause photoelectric effect. Also, in some cases, we may have the light having energy that is in excess. This means that or the energy that is higher than the cutoff energy. In this situation, some of the energy is used as cutoff energy, and the excess energy is converted to kinetic energy, which accelerates electrons away from the metal surface. Now, as I have said, the cutoff wavelength is the minimum wavelength of radiation that will cause photoelectric effect, and the cutoff frequency is the minimum frequency of radiation that will cause photoelectric effect. Now, the minimum frequency or the cutoff frequency is given by F. There is a 0 here, so this is F naught. When there is a 0 here, it means this is the cutoff frequency. And also is given by C. This is the speed of light divided by the cutoff wavelength. So we have the cutoff wavelength being this lambda, and we have a naught here. So where F0 is the cutoff frequency and lambda 0 is the cutoff wavelength. And also we have C is the speed of light, and it's a constant, and it's given by 3.0 times 10 to the power 8 meters per second. So this value is the speed of light, that this is the speed that light travels in a vacuum. And X and the photoelectric effect, also we apply that formula, which is 3.0 times 10 to the power 8 meters per second. Remember, we have a radiation that causes photoelectric effect, and that is ultraviolet radiation. And we, in our previous topic, that is electromagnetic spectrum, we saw that all radiation travel with the speed of light. So that's why we have this parameter here. Let's go now direct to the question. We want now to calculate the threshold frequency or the cutoff frequency. The cutoff frequency is given by the speed of light divided by the cutoff wavelength. We substitute the values in this formula. We get it is 3.0 times 10 to the power 80 meters per second divided by the cutoff wavelength, which is 3.310 times 10 to the power negative 7 meters. And if you key in these values in your calculator correctly, you will be able to find the cutoff frequency as 9.063 times 10 to the power 14 hertz. So 9.06 times 9.063 times 10 to the power 14 hertz is the minimum amount of frequency that can cause photoelectric effect. So let us look at the second question. The second question reads, the work function of tungsten is 4.52 electric volts. Find the cutoff potential for photoelectrons when tungsten surface is illuminated with radiation of wavelength 2.50 times 10 to the power negative 7 meters. And also we are given the Planck's constant value to be 6.626 times 10 raised to the power negative 34 joules second. So we are given the work function of that method to be 4.52. So this is the energy that will cause photoelectric effect. And we said in some situation there can be a supply of energy that is in excess. For instance, we are given this this material, tungsten material, illuminated with a wavelength of 2.5. So we are not told if this wavelength is cutoff wavelength, but possibly it can be a wavelength that will produce higher energy than the cutoff energy. And we said in such situation, some of the energy is used to cause photoelectric effect, and the excess energy is converted to kinetic energy, which moves electrons away from the metal surface. So we are going to solve that question. We are supposed to calculate the cutoff potential. So we have this E naught. This is the work function, or the cutoff energy is given by 4.5 electronic volts. We can convert this energy to joules by multiplying 1.6 times 10 to the power negative 19 coulombs. But before that, let us just continue with our question. The energy of the photon. Now the energy of this radiation that is illuminated on the tungsten is given by HF. This energy can be more than the cutoff energy, and because we are not given the frequency, we can substitute frequency with C divided by the wavelength, because frequency is given by the speed of light divided by wavelength. And therefore the energy of the photon will be given by Hc divided by the lambda. Hc are constants. Remember, H is the Planck's constant and C is the speed of light divided by the wavelength. And if we substitute these values in this formula, we get the energy of the photon. The energy of this wavelength is 7.95 times 10 to the power negative 19 joules, and we can convert that one to electronic volts by dividing 1.6 times 10 to the power negative 19 coulombs, and we get the energy of the photon is 4.97 electronic volts. So as you can see, 4.97 electronic volt is higher than 4.5 electronic volts. This means that the light energy, the radiation that was illuminated on tungsten is of higher energy than the work function. That means that if we subtract this value, so 4.5 of this energy, or 4.97, will be used to cause photoelectric effect, and the remaining energy, which is the difference between these two kinds of energy, will act as the cutoff potential. And the cutoff potential will be given by the energy. There is an error here, so energy should come first, minus the cutoff energy, so it should be E minus E naught, and that one is 4.5 electronic volt times minus 4.97 electronic volt, and we get 0.45 electronic voltage. So this is the cutoff potential for photoelectrons.